everyone. Welcome to this BAKERpedia seminar all about optimizing production with vision inspection data. I'm Dr. Lynn today, your host, and this seminar is brought to you by KPM Analytics. KPM Analytics supplies instruments that measure critical quality parameters of incoming ingredients, analyze products during the baking process, and ensure final product quality. Their comprehensive range of analyzers are used by food producers throughout their production to improve efficiencies and also to ensure quality and protect their brand. KPM Analytics is backed up by 100 years of experience developing advanced products and processes for quality assurance and process control in baked goods manufacturing. If you need any QA help, contact kpmanalytics.com. Today, we are joined by Andrew McGee. Andrew has over 30 years of experience in the bakery industry. He has a Bachelor of Business from the University of Technology in Sydney, Australia, and joined the bakery industry in Australia in 1987. When Andrew arrived in the US, he joined Northeast Foods in Baltimore, working for the Patarakis family in the bakery supplying McDonald's restaurants. Andrew then worked for iPro Systems, inspection systems for bakery products for over 10 years, heading up the North American operations before joining Schaefer Mixers, which is part of the Bundy Group. Now, in 2017, Andrew rejoined iPro Systems, which is now part of the KPM Analytics Group, which includes iconic bakery equipment brands such as Chopin, SensorTech, Process, Sensors, Sightline, and Unity. So welcome today, Andrew. I look forward to your presentation.
No problem. Thanks, Lynn, for the introduction. So today we are talking about I work, as Lynn mentioned, I work in the iPro part of KPM, where we do bakery inspection systems. So bakery inspection is sometimes a little scary. We're inspecting products, and perhaps sometimes we're rejecting them off the line, and it really makes people nervous, especially senior management. But really the most important thing about inspection is the data that you're collecting. Like so many things in our processes, having hard data makes it much easier to manage the process. So let's talk about how vision data, inspection system data, can be used to help you along. So as we know, it doesn't matter what product you're producing. There, in a commercial industrial bakery, there is a lot of processes involved. And typically in baking, mixing the dough, forming, proofing, baking, cooling, and then packaging. So I just attached here some links, which this presentation will be available after the presentation. But we have some links just to some videos that are on YouTube, just give people a bit of a rundown in the different production processes for the different products. Because that's the one thing I like about my job. I've worked in the baking industry, but I love to go to new baking facilities to see some of these products that I've never seen being manufactured before. Hopefully that'll give an idea to people of what different processes are, and you can start to see how vision may be able to be used in that process to help improve that process. And as we know in bakeries, it's a very simple process. You just put flour on one side and a perfect product comes out the other side. It's so easy, it's fantastic. Not really that way at all. It's affected by a lot of variables, but the challenge for a baker is, okay, we want to have products that satisfy our consumers. In the bakery, we want to produce products that are consistently good quality. And then, of course, we have to make money doing that. As we know, lots of inputs into a baking process. Ingredients, of course, is one of the biggest variables. But even environmental factors can have a big impact. The weather today, the humidity today, the temperature today. Also, just the processes are used. We can have one company having multiple facilities producing the same products in different facilities using different equipment. So again, how can we make sure that we are delivering a consistent quality product to our customers from those two different facilities? Obviously, we have issues with labor, making sure we have people well trained and able to perform their tasks satisfactorily to produce that consistent quality. So how do you ensure you're delivering consistent quality throughout your production process? When I first started in the bakeries, we had a foolproof mechanism. We were producing, 800 buns a minute. So it was kind of hard. We couldn't inspect every single one. So what we did, like most places, we introduced sampling procedure. So in this particular case, I'm showing a sampling station from a cracker manufacturer. And I'm sure all of you have something like this. If you're in the bakery, if you have some station like this, where you're pulling samples from the line to take some measurements, which are then used to monitor the process. If some of those measurements are out of parameter, then you're going to try and take corrective action to correct that problem. And you may even want to maybe quarantine some product because, okay, the sample that I've taken at this point in time is not satisfactory and we don't want that to go to our customer. And what are we looking at? Lots of things. Physical dimensions of the product. When you're looking at the shape, bake color is always important, appearance. And of course, you may even be doing some sensory evaluation as well. What's the texture of the product? What's the taste of the product? Does the product smell right? And then, of course, you may be even also doing some moisture analysis as well. You can see over here we have an NIR moisture analysis there. And you're probably weighing the product as well. Okay, so what are we trying to do when we're setting up our sampling plan? Are we just taking as many products as we can or taking a few here or a few there? Hard to say. But what we're trying to do is design a statistically valid sampling plan that is going to truly represent our production process, the variation that we will see in our production process. And typically, when I started in the bun bakeries, we were taking like 12 buns off the line every 20 minutes. And so we were taking those buns off. We were then going to that station where we would measure the height of the product, measure the diameter of the product, measure the bake color of the product, perhaps using a Minolta BC10 or some other tool to measure. We might be just using a photographic reference where we would score the color. But again, we were doing that sampling, and so as I mentioned earlier, if we're producing 800 buns a minute, that's a lot of product an hour. And so I'm going to look at 36 of those products, measure them, collect the data, perhaps put them on a little trend graph, and try and determine, okay, how is my production process running? How close to our operating parameters are we? And what we're trying to do is to say that typically for most of the measurements, it is a normal distribution. So we are trying to understand, okay, what is, the standard deviation of the measurements? Because we know that we're using 3 standard deviations that will show us what our range of variation is. So that's what we're trying to identify. Okay, what is that range? What is that range of variability? So when we switched to inline inspection systems, and this was something that we did many years when I was in the bakeries many years ago, we kind of got our brains blown apart because remember we were doing 36 buns an hour on a bun line, and now I'm looking at 100% of the product coming off the line. So 48,000 products, I'm measuring every single one and getting some statistics on every single one. So if our sampling program that we were using when we were pulling the 36 buns per hour off the line was really truly representative, then the data should be pretty similar. The standard deviations that I'm calculating using my sampling plan should show me that, okay, my distribution is this. And then when I get the 100% data, it should be pretty close. That's the ideal world that we're in. Unfortunately, that wasn't the world we were actually in. So let me show you the next slide. Well, let me show you an online inspection system first. So you can see this is on a biscuit or a cookie line, depending on what part of the world you're in. So here is a system that is using top color inspection, bottom color inspection, and a 3D camera to measure the height profile of the product. And every single product's being measured. We get 3 images for each of those products, and then from that we decide if the product is acceptable according to the tolerances that you've set. And any bad product, as you can see here, using an air nozzle array, we're rejecting the bad product off the line. But again, we have data on
That's
every single product.
really impressive, Andrew. I just have to say that. That is that rejection is very low compared to the output of the system.
Exactly. And also the important thing for this particular line is on this biscuit line, they're doing lots of different shapes and sizes. And so we have to make a system that can inspect all those shapes and sizes, but also that can reject any bad product off the line. So because the key is for rejection, we only want to reject the bad product, not the one next to it, not the one before it, just the bad product. And so that's a big part of the design of a vision system, so that we collect good data, accurate data, but also that when we're rejecting a product, if you have rejection on it, that it's only rejecting the bad product. Okay, so now I've gone from my sampling of 36 buns an hour, I'm now looking at 100% of the product that we're producing, getting measurements on 100% of the product. And this is kind of what scared us, because we're saying that when we looked at the sampling, we had a bun height that was averaging out at 60 millimeters on bun height, the mean. That was quite acceptable, well within range, well within the customer specification. We had a standard deviation of 0.9 millimeters. So using the normal distribution curve, we felt pretty confident that we had a range of product that was somewhere between, the height of the product was somewhere between 57.3 and 62.7 millimeters, where 99% of our production was lying. Pretty good, all in the green range, everything's wonderful. But the 100% data, and we were calculating the mean of that. And our mean was a little bit different, okay? More data, yeah, we're going to have a more accurate mean, but again, not so different from what we were calculating previously. But the standard deviation was unbelievably different. It was, 2.5 times different. So it's really quite scary to us, because now using normal distribution, again, we were saying, hey, we're all the way down at 52.7 millimeters is our shortest bun, and we could be as high as 65.3 for our tallest bun. So again, these are in red because these were actually outside our operating parameters and our customer specification. 59 was still well and truly within, and so straight away we're panicking. We are absolutely panicking. We're saying, "Oh my gosh,
too.
what are we going to do?"
Really high standard deviation.
What had happened?
Okay.
Nothing had changed. It was same production process, same raw materials, same everything. It's just that it's the next day now when we've turned on our inspection system and we have a lot of information. And to be honest with you, whenever we turn on an inspection system, we never turn the rejection mechanism on for day one. What we want to understand is what's your current process, so that you can understand exactly what your range of variability is. So all it meant now was, hey, we know what the truth is. We know what our range of variability is, and then now we can manage to it. Products that we're sending to the customer were the same in both examples. They were the same. It's just that I thought they looked like this on the left, when in reality they were really like the distribution that's on the right. So again, getting the information in perspective was a very important part of the process. And so what was the difference? Why did we have this big variation? And it's something that I'm sure all of you have experienced if you're working in any sort of quality control role. Sampling bias. Do we really select products randomly? I know myself, when I'm picking buns randomly, am I closing my eyes and picking a bun? No. I'm picking a bun. Oh, yeah, this is a good representation. But normally, unconsciously, I'm probably picking a good-looking bun versus a bad-looking bun. What part of the line am I picking from? Well, I can only reach this far, so I didn't get one from the far side. So I'm not really getting a true sampling of what's going on in the process. And you guys know that in a process, there may be some variation between the middle and the edges of a production line. There may be the beginning of a batch, the end of a batch. You'll see all these variations that occur. And that's what we want to understand. What are these ranges of variation, so that we can now try and manage our process to optimize it so that we can minimize that variation. There's also measurement bias. We love to do the test when we go into a bakery and say, especially on a bun, a soft product, say, okay, here's a caliper, guys. Let's get an accurate measurement of this bun. So we'll give 5 calipers and the same bun to 5 people using the same caliper, and they'll all be very precise. Let's measure the height. Let's measure the diameter. But of course, how I measure the product, where I measure the product, how much pressure I apply to the caliper to measure the height, will end up me giving it a different measurement, perhaps from the person standing next to me. And so how we use the measurement tools that are available to us also can bias the measurements. Good thing with an online inspection system, nobody has to touch the product. Nobody has to use a caliper, and we don't care about the compression that's being applied because nobody's using a caliper anymore. So that can help us also to get more objective measurements. Here's some other things that can happen to prejudice a manual inspection. From people have different ways of measuring. And so there's lots of, and you get this slide here, but so it's really, opportunity for sampling to be not as representative as we think it is. So let me just show you another video. This is showing you a video, and this is on a bun system again, and I apologize for people that are producing other products, but this is just give you an example of one baked product. But it applies to all baked products. So in this particular case, this is the interface of an inspection system. It's showing you all the data that's available. And I'll be honest with you, it's a lot of data, and it will be a little scary to you. I'll walk you through. So this is the sort of the front page, and right here is a summary of the key measurements that have been identified for this product by the customer. So again, in green, the measurements are within specification. Yellow means, okay, I'm going out of specification into a marginal area. Maybe I need to look at my bottom color here. This is showing you the number of products a minute that we're inspecting. Again, good from throughput. This is showing you how many rejects I've got from different parts of the conveyor. In this particular case, we're breaking it into 3 zones. And you can see that there's more waste over on currently. Partial is the last 2 minutes. Total is since we started the production run. But in the last 2 minutes now, okay, I've got some rejects in one particular zone. Here is looking at, okay, what's the overall reject trend for all reasons, percentages. I can also look at it in absolute numbers. And then I can look at individual reasons, see, okay, how much waste is coming from that particular defect. Up here you can see we have some statistics on how many products have been inspected, how many were rejected, how many were good. That's very useful. You get that in percentages, but also in absolute number. Up here on the right, you're actually getting some images that we save of the last rejects. So in this particular case, this is the 3D camera, this is the color top camera, and this is the bottom color camera. So the good thing about that is if I have a product that's been rejected, I'll see it get rejected, but I can go and look at these images and see the reason that it was rejected. And that's a very powerful tool because management will stand in there saying, why is this bun being rejected? It looks quite good, but this allows you to have that information. Here we have a Pareto analysis of the cause of rejects. This is the most powerful graph that I look at when I go into a bakery because straight away I can see, okay, what's the cause of my waste? And then look along the production line to see, okay, what is causing that particular defect? And then what corrective action can I take to do that? Here we have trend graphs on a measurement. So this is a height graph. I can zoom in and see a particular point. On this graph, I believe we're plotting every 2 minutes, we're plotting the average measurement for height for the last 2 minutes of product. So in going back to 800 pieces a minute, then that's 1,600 measurements that I'm averaging. And then, of course, we have histograms as well that show the distribution, how many products, where, what the distribution of measurements are of the products. And again, to the summary page, key measurements, partial is for the last 2 minutes, total is for the production run in total. And this is just, again, on the key measurements, we can have a look at the trend graphs very easily and see what's going on. Okay, this is what I was talking about before, where we save images of the last, in this case, 20, it could be as many as you like rejects. And so I can click on the image. The blue box is the very last reject. I can click on that. It'll give me the measurements for a particular product, and it'll highlight in red the reason that it was rejected. So it's very, very helpful to understand what the defects are. You can see here some have got little blisters on there. And so depending on how you've got your system set up, it can reject those defects. For maybe your food service customers, you need to have a very perfect product. Maybe for a retail supermarket, it doesn't need to be quite as perfect. But again, you set that up by individual product. And this is the bottom again. You can see we have some white ring on this particular product. Okay, so let's say, okay, I have this data. I have a plethora of data, so much data. Now, how can I use that to help my production process? So when I first started looking at online data, okay, my brain is already blown because I thought I had this production process and now I have a much more variable production process. Well, it hasn't changed. I just know what the ranges are now. So what we have here is, for example, on buns on a product type. So this is just a trend graph. So again, this is plotting the mean for measurements taken every 2 minutes. But you can see here that the height is varying quite dramatically. Say from in this case, you can see it's from 1.59 to 1.97. But if you look also, there appears to be a bit of a cycle to it. You know, it starts off small, the bun gets big, and then of course now we drop down to small again. And for those of you that produce buns, you know that a lot of production process for buns, the batch process. So we're mixing the ingredients, making one batch, using that batch, and then while we're doing that, we're mixing another batch. So what's happening here is that as the batch gets older, so it starts here, as the batch gets older, the yeast is working, it's developing the dough, it's making the dough, taller and more active. And then when I start a new batch, of course, it starts down here again. So again, as the dough gets older, the product can get taller. So, and in some cases, it can actually be the opposite. When I first start running the batch, the yeast is very active, but as the batch gets older, it's no longer so active at the end of the batch, and so the product is not as tall. But you can see I have this significant variation. We call it the sawtooth. And that can be problematic for me. And in this particular case here, we were having a batch. Each batch took 22 minutes to process. The highest value was 1.97 inches, and the minimum value was 1.59 inches. And so we have a range here of 0.38. So what can we do about this? This was perplexing to us because in this particular customer, they were toasting the product. So a tall product would toast darker once it got to the restaurant than a smaller product, and they didn't like that. They wanted to have a consistent toast. So we needed to try and minimize that variation. So what we ended up doing was doing more batches more frequently. Mm-hmm. So the batch processing time now was only 17 minutes instead of 22 minutes. In that particular case, we were going from a range of max height of 1.89 and the min value to 1.64. The shortest buns were 1.64, the biggest were 1.89. And so the range was now 0.25 inches. So by changing the process, and we had the capacity to be able to do more batches an hour, we were actually able to reduce the variation in product height. And that was very important to our customer. But there was also a corollary to that height is also indicative of the color that we'll get in the product. And it's not rocket science, because what we found here, this is a graph of bake color, that the taller the product, the closer it is to the heat source. And therefore it would get baked more than a shorter product that was further away from the heat source. So depending on the design of the oven and the mechanism involved, and whether it's a convection or direct fired oven, but we was definitely seeing that as height varied, so did color. So again, by reducing the batch time, we were able to get the variation in color, we were measuring in L values, down to 7.2. Actually, after this, they were able to get it down to around 4 to 5 L values, which was much lower. Up until then, it was much higher. It was 10, 11 L values. So where we were having a lot of variation in color across the production run, now we were narrowing that down. So using the data, the key things about using data are you must identify what measurements are important for each product, and what's important to either your process, to your customer's process, or to the end user's quality assessment. You know, color is usually important, but there will be a lot of them. And they may differ by product. You must then focus on those key measures. There are so many things that are being measured, but focus on the ones that are important. And that may be different by product. And then for these key measures, try and use the data to correlate them to other parts of the process. So what happens when I change my ingredients? Do I get a change in the measured quality of the product? Scaling weights, proof settings, environmental conditions. But the key is to be very methodical. There are so many variables, it's very easy to get lost in that process. I think that's probably covering off. How are we going for time, Lynn?
Time is great.
So I'll let it go. That what I will show you is just one video later on that I would like to show you, just so you can see. This is a
wonderful videos.
sorry, yeah, I love
It
videos
shows
too.
so
So this is
much,
an inspection system on a biscuit line. So up
Yeah.
here on the right is actually the vision system. So we have the color camera and the 3D camera doing a top inspection. But what we've been able to do on this one, this vision system, is we've been able to add a gantry robot here. This randomly selecting, or based on a plan, sampling weight here. So we can't measure 100% of the weight of the product, but we can randomly, we can set up a sampling plan to be able to measure the weight of the product. So what it's doing here, you'll see, it's picking the products up and then putting them on a scale, which is right here in the foreground. But also over here, we have an NIR moisture meter, which is also scanning across the lanes of the product and taking moisture measurements as well. And again, in a very methodical way, looking at each lane and collecting the data accordingly. But then we are actually have all this data in the one database with the vision system data, and then we can help to try and correlate, okay, how does weight affect size, color, shape as measured by the vision system? And same with moisture, the NRI moisture measurement. How can we correlate that? I just wanted to share that.
I love it. I love the inline moisture measuring system because that really determines the output of the oven. That's amazing.
For sure.
Yeah. Okay, so I had a question for everybody. If you could just type in the chat what kind of products you're producing, Andrew and I would see if we can answer more questions along those lines as well, because we know that today we, talk a little bit more about hamburger buns, and we know that not everybody produce hamburger buns. So I would like to know what kind of product you're producing, and if you could type in the chat, that'll be awesome. So right now, that's a great presentation, Andrew. Thank you for sharing the videos. I'm always so just amazed by how your systems work in those videos. Now, let's go to the questions.
I'm glad you asked, because the answer is yes. You have all this data and it's being provided to you in real time. So it's very, why can't we use that data in real time to adjust the process? And the answer is yes, we can. I'm going to share my screen again. I'm just going to find the right slide here to be able to show you, give you an example of how a system can be used in that, the data can be used in that way. So this is a system where we're using bake color to control the last two zones of the oven. So in this particular case, we have the customer has determined, okay, these are the acceptable color ranges: dark acceptable, light acceptable, and target. And so these are measured objectively by the system. And again, coming out of the oven, we're measuring every single product, and we're working out, okay, what the color of the product is. Over here, we have information coming from the oven itself, the last two zones of the oven, about actual temperature, and the yellow one is the set point. So what the system's doing is using some sophisticated AI algorithms to look at the color of the product coming out, and again, across the whole band of a biscuit oven, and then using those sophisticated algorithms to set these set points for the oven, monitor the color. It's a self-learning algorithm. So as the system makes a change up here by changing a set point, it sees the result of that as far as bake color, as the product comes through in 5 minutes time or whatever. And then knows, okay, that's what the change I made, this is the result I get, and continues to learn and learn and learn. So the longer the system runs, it becomes more and more responsive to the process. And again, automatically controlling the oven. If an ovensman that doesn't have an opinion, doesn't matter whether it's Lynn or Andrew, it's always going to be the same color. I like my cookies a little dark. No, none of that anymore. And then and it never looks away. It never takes the ovensman never looks away, never takes a break. Now, typically where this is installed, where they might have an ovensman on every single oven, they are usually able to share, put one person between two ovens because the system is doing the bulk of the work. The only time the system, a manual operator would intervene is if there's a big problem, a break in production, some other feature. But even so, the automatic system can accommodate a lot of these little changes, whereas a half-filled oven or something like that. So yeah, we're using feedback loops in this, but also in tortilla production, where we're controlling the pressure on the press because they might be pressing 9 tortillas at a time. Again, if the press is not properly adjusted, the tortillas on one side will be a different diameter than those on the other. The system can see that and automatically make adjustments, send signal back to the press to make those adjustments automatically. So again, that's the future for us as far as using inspection data, is to automatically control the process. And keep in
That's
mind that,
really
sorry.
Sorry, that's really impressive. And I didn't mean to interrupt, but do you provide the service for the data feedback? Or obviously you're not a oven press or
Correct.
an equipment provider. So how does that work? What if someone has an existing system already?
Yeah, so what we always try and understand is work with the vendor. So, for example, if you're using an EMA Forni oven, if you're using a Bueller oven, we would want to be interfaced very tightly with that vendor to understand their control systems. And then we're not really controlling the oven, we're just sending them a signal, and then the oven control mechanism is then making the changes to the oven. So yeah, that's a key part of it. And obviously older equipment is harder to do because it's all analog. The newer
Mhm.
equipment is much easier. And it's not just temperature that we're adjusting to. We can be looking at fan speeds, humidity of the oven as well, and things like that. And a lot of the newer ovens, we're able to work with those manufacturers so that we can help send signals to them so that they can control the process pretty finely.
Amazing, amazing. I love to hear that. This is the absolute future of baking. The immediate feedback and the ability to, not rely on operators to determine what color they want. That's a huge deal. I mean, it happens so many times, right? Like change of shifts, change of oven operators, and all of a sudden it's a certain color, a certain size, and it's just uncontrollable.
I
So,
can remember us having some dark product and coming back, the production manager saying, "Don't worry about it, Andrew. Let me take care of this." So I came back 2 hours later, and he said, "That looks much better, doesn't it?" And I'm going, I can't really tell. It looks the same." But at least with an objective piece of equipment now, I have a trend graph to see what happened, and I can see exactly
yeah,
what the color measurement is. But yeah,
same
it
thing
takes
happened
the
to me
guessing
as
out of it.
well.
Yeah, for sure. So this is actually inspection. So the product's coming in, loaf inspection's coming in. Here we actually, we just need a little space between the products, and then the products are being inspected. And again, color and camera, top color camera, top 3D camera, and then we have a rejection mechanism as well. Let me show you another one. In this particular case, we actually have load cells, inline load cells on each of these conveyors here. So as the product comes out of the cooler, coming towards us. And this system is set up so that it can do different size products and different shape products. We have a guide on the right-hand side there that centers the product up so that we can see it. You can see here, this is the rejection mechanism actually. The weight mechanism is here. But again, the key for a rejection mechanism is that we need to be able to reject the individual product that is defective, not the one next to it, not the one behind it, not the one adjacent to it. So
Interesting.
here we go.
That's really fast.
Yeah, there's
And
a
it's good
lot
to see
of
not a
bread
whole
coming up.
bunch of things being pushed to the side.
Yeah. This is the one that has the inline weight check. Let me show you this. If it'll go. If it'll go. No, that's not working. I apologize.
This is amazing.
Yeah, it's here. It's coming through, and as I say, there's an inline weight check, checking the
Okay.
product there. So anyway, and this is as I say, this is the guide. It's using ARB technology to align the product, and then we use a spreading conveyor to spread the product out. So we have the space, and then we go through the inspection system. And initially, there is, as I say, the individual weight sensors on that conveyor on the way in to do the individual weight checks. And then we have the color and the 3D camera inspecting the product, and then we have the rejection mechanism.
I have one question on this one. So when you implement inspection systems like that, what is the ROI, as in, have you helped any plants eliminate positions that does the checking?
Yes. So, for example, if we go back to that video that I showed of the weight check and the NIR, again, the problem we had with our earlier inspection systems, we were doing physical dimensions, and we were able to measure stack height using the 3D camera and length and width. And we're even able to measure bake color, but they still needed to be taking product off the line to do a weight check, and also to do an NIR moisture and moisture sensor analysis. So in that case, it was kind of like, there wasn't a really good payback. But then once we went to a system where we now were able to automate that, again, they were able to eliminate a person between two lines. They still had one person floating between the two lines, and I think ultimately they might be able to get away from that. But then they were able to get a significant improvement on their payback. In something like this on a bread line, typically the way the bakers are operating, they have some point where there's an inspection going on. Either it's just before the slicer or the bagger or something like that, or maybe in this area here coming out of the cooler. And so again, with an inspection system that's inspecting it, they can usually eliminate that position or task that position doing something else, and therefore get a payback on the system. That is the challenge, though, because we need to be able to get the customer a payback so that they can justify the investment for sure. And actually, in
Yeah.
buns, that was one of the challenging things for buns, because we're doing 100% inspection, but coming into the bagger, they still needed to balance the lanes of products. So they still had somebody there. So in the end, we used vision to be able to do an automated laning system as well as the vision system. Good for
Nice.
KPM because we're now selling more equipment, but actually good for the bakery as well, because now I could eliminate a person and get a
Oh yeah,
payback on the
for
total
one
investment.
real person standing there just directing the buns. I never like really understand that.
It's not a fully rewarding position, It's
No.
not one of those ones that you think, oh yeah, I'm feeling good about this today. Well, you'll just have to take my word for that. No, it's very important actually, because that is the first question that's going to be asked. If a bun comes off the line, or a bread comes off the line, or a biscuit comes off the line as a reject, and then somebody looks at it and goes, hey, that looks pretty good. Why has this been rejected? So as I mentioned before, we can go to the image and we can click on the image of that particular reject and say, okay, why was this rejected? And it'll highlight in red the reason. So it may be because it was too small or too large. But okay, how do I know that that's accurate? I'm going to get my caliper out now, and I'm going to try and measure the bun or the biscuit. And we've already talked about how sometimes calipers cannot be that, it can be a little bit variable in measurement, just a little bit, especially
Objective
on soft.
depends on who's using the caliper.
Yeah, it depends on who's using the caliper.
If it's me, I'm very gentle. If you ask another man doing it, they're like crushing it.
Yeah,
So
we like to be
pretty
sure that we're
subjective
measuring the
there.
top of it exactly. So that's problematic for us. So again, even somebody getting a caliper say, well, hold on, this is saying it's 12.1 millimeters. Well, I'm measuring it here, it's only 12 millimeters. It's not too big. It's actually the right size. So the way we validate that is that we have some calibration blocks that we recommend that the bakery put through the system, usually every week, usually on the down day or just before you start up. And some people are doing it more often. Some people are doing it per shift or per per every day. And it's a very quick process, just the calibration block, select the calibration process, put the disc through 2 or 3 times. It'll actually calculate, and that's a very hard plastic block. And that way, the measurement's not changing. And the system will measure that product 3 to 5 times. It'll calculate the standard deviation. And if everything's being measured accurately, we're good to go. That the system's measuring very accurately. If there's some variability, it may be because the optical windows need to be cleaned or something like that, or there may be a problem. There may be some camera or laser that's got out of alignment. But again, that's the alert to you. Okay, hold on, this is not measuring accurately. I need to check some things, or I need to get in contact with KPM to help me diagnose this issue if there is an issue. But typically, I'd say 90% of the time there's no issues, 99% of the time there's no issue. So that when somebody comes and the boss comes and says, hey, why has this been rejected? You say, hey, it's too small. Look at the image, it's too small. Well, how do you know that's accurate? Hey, we calibrated it this morning. We know it's accurate. So it's better to do it regularly rather than leaving it. If you haven't done it for a month, you might say, oh, well, I did calibrate it last month. And that's very convincing to your boss to say, a month ago? Well, is it still accurate? Oh, yeah, I'm sure it is. Yeah, no problem.
And I also just do think those upper management questions need to be communicated prior to implementation of such systems, right? I mean, this is a lot of data collection you collect. This is a lot of samples, and that needs to be communicated too, right? And not just implemented without approval from upper management. I think that form of communication is important, and understanding the system is important. A lot of the times, these systems are requested by our customers to be implemented. It's not something that we want to do as bakers, right? So when our customers ask for these data, they want to make sure that you are processing the product at the most efficient way that you can. It's not their intention to make you do it at last, right? So this
Correct.
is why, your customer, upper management, middle managers, floor operators all need to come to the table and understand how you collect data, what's acceptable, what's not acceptable, and hopefully that discussion ends up in something like, how do we reduce the standard deviation in those things, right? And how do we fine tune our process so that we reject less? It's not just the vision systems problems, it's the communication, it's the work together, it's the work around and the work through. And that's really important. It's not just data and whether it's not correct or not. That is like so far from the center of the conversation.
And to be honest with you, I've had a lot of experiences with customers where the way they're setting a specification is totally removed from your process capability. And that's the biggest challenge you're going to have as a baker, is that sometimes they've got 20 buns in the room and senior management saying, oh, I like that one, I like that one, I like that one. They'll pull them aside, they'll measure them, and they'll say, okay, great, here's what we want, and here's the standard deviation of the ones we measured. So plus or minus 3 standard. Oh, yeah, this is the spec. It's plus or minus 2 millimeters. Okay. And we had this experience that for a particular product that was a tall product, a lot of that is yeast, and that's a very variable product. And we physically could not match that specification because they were setting it arbitrarily, not based on the process. But now I could go and have a conversation with my customer and say, okay, here's our production process, here's the range of variability. We're working to narrow it over time, but really, and we've been doing that for whatever time, but this is really the best we're going to be able to do. And is that going to be acceptable to you? And 99 times out of 100, the customer would say, okay, let's see that this variability, is that acceptable to us? Is the variability in color acceptable to us? As I mentioned before, the toaster, if it's the smallest product you're going to produce, or it's the biggest product it's going to produce, is it still going to work in our system? And we were able to always work it out with the customer so that we could have a specification now, or an operating parameter for our production process, that was achievable by us most of the time and satisfactory to the customer. And again, as you mentioned earlier, minimizing the waste, because in the end, somebody has to pay for the waste, and we don't want to be throwing product away unless it's absolutely necessary. But again, having the data now to talk to the customer rather than just saying, "Wow, that's too hard," is very it's not a good conversation. But now I have the data that I can share with my customer. And where you have multiple facilities producing for the same customer, you can pull data. And so it's not just you. I know when I was in the bakeries, I always worried, well, maybe we're not doing a good job here. But once you started comparing data between different facilities, you could see, no, the process is this variable. And let's have the conversation with the customer. And as I say, 99 times out of 100, they were very open to that discussion, because now you're not trying to tell them a story, you're showing them some facts and showing them something about your process. Hey, they'll still push you to get narrower and narrower parameter, narrower and narrower ranges, but again, at least we're having a dialogue based on facts rather than a dialogue based on sentiment.
Correct. Very good. Thank you.
Absolutely, yeah, that's a key thing for all inspection systems, because toppings are the one. Another story about sesame seed, especially with the varying price of sesame seed. As the price of sesame seed goes up, the senior manager wants to put less and less sesame seed on the product because it costs so much. And so we did a lot of focus groups with the customer to say, okay, what's range of acceptability? And it was quite interesting to us. The customer was that the customer, the end user, the actual consumer, was actually quite flexible. They were more interested in just saying, well, as long as there's sesame seed on it and it looks like it's meant to be on it, that's really enough for me. Exactly what you're talking about. The person that wrote the question is, the important thing for us is, okay, do I have enough sesame seed on the product? Also, more importantly, is it well distributed? Because I can have the right amount, but it might all be on one side, and that's going to be visually unattractive. So again, we have the ability, and the way the system does this is by looking at the colors that go to make up a product. When you set up a product, you learn all the colors that make up the product, and the system learns that these lighter colors here are actually seed. You might have poppy seed and sesame seed, or you might have bran and sesame seed. The system using AI and using colors, and the AI can see by looking at the shape of these items, but also the color, that okay, this is not bun, this is a topping, and then you can classify however many toppings that you need. For example, when we get down to pizzas, of course, you have mushrooms, olives, salami. Again, the system is able to detect all those different things as different toppings and measure them, and then work out whether there's enough there, and also whether or not it's well distributed. The number one complaint in pizza manufacturers, industrial pizza manufacturers, is, hey, there's not enough pepperoni on my pizza compared to the photograph on the box. And so pizza manufacturers are very interested in making sure that they're sending out to the customer what they're promising on their advertising, and also on the exterior of the box. Absolutely, yeah. So obviously we have, let me find the slides for you, and I'll share. So in this particular case, this is using a 3D camera, the 3D camera. So we're getting a very, detailed profile, and it can also be on, cookies or crackers or other things. So we can see the volume of the product. We can calculate the volume of the product. We can calculate length, the width. We can calculate the height. But also shape is a really important one. And I've got another slide here. Let me get to it, which will show you a classic example of, okay, here it is. So, example, in this animal cracker scenario here on the bottom left, the system needs to be able to determine, first of all, what shape it is, and then whether or not it's cracked. And so you can see here, the system can see that this is a bird. You can also see that this is a bird, but it sees that the leg is missing. So straight away, it identifies that as a reject if you want to set it up that way. So again, shape recognition is very important for us. But again, we can looking at volume as well. On cookies and crackers, for example, we're looking at, I don't know whether I have an image of it here. This is a croissant, but okay, yeah, here, for example. And this is another good example. You're talking about toppings. So, for example, on a chocolate chip cookie, we want to have a certain amount of chocolate chips present, visible. that's what the customer wants to see. So again, we can measure these two things differently. We can measure the bake color of the dough, but we can also measure, okay, what surface area and how evenly distributed the chocolate chips. Over here on the 3D here, you can see that we are measuring the base of the cookie, but we can also measure the topping. In this case, I think it's a piece of chocolate that was on top of the cookie. Again, if that's not right, too big, inclined or whatever, you can set a parameter to be able to reject that. And you can see in the croissant here, for example, we can measure very detailed profile. And again, you can set up a parameter to accept or reject a product. And that's a big part of what KPM do, is understanding what the key attributes are and then working out a way to measure it, but not so that you need a science degree to be able to understand it and adjust it. It needs to be very simple so that the user can understand, okay, this is rejecting stuff that shouldn't be rejected, so I need to be able to adjust that tolerance. So we try and we work out a way to set up a tolerance that is very easy. Usually it's a slide or some description, so more or less, and makes it very easy for an operator or a supervisor to be able to make that adjustment. You can see on pastry here, we're looking at different shapes and things like that to say, okay, that's unacceptable, but this is acceptable, this is acceptable. But again, you guys know about your products, and so that's why we listen to you and say, okay, you tell us what's acceptable to you and what's not acceptable. Sometimes we're measuring stuff that really is of no use to you. We will take it off the interface, because what's the point? If it makes a difference to you or your customer, then we can work out a way to measure it. You are right that in this particular case, we are the sampling method set up the robot, so it knows I'm going to go to the outside lanes, the middle lanes, or the outside lanes, depending on how the customer wants to do it and how many pieces they want to measure. And you can see here it's being dropped on a static scale. So yes, that's the static scale. Now, inline weight checks is possible, and I think I showed you. Let me move this over here. Over here, this is the inline weight check here, right here on the left-hand side. This of these conveyors has a weight sensor on it, and it's measuring inline weight check. So for bread, it's possible. For buns, it's not so possible, basically because the buns are randomly distributed on the conveyor. For biscuits, theoretically, it's possible, but whenever I've seen it tried with an inline weight sensor, the product is in lane, so it's very easy to do that. But it just doesn't seem to be a reliable way to get absolute measurements. The customer has now defaulted to this robot to be picking the weights, because that's very, okay, I have one piece and I'm measuring it, I'm getting data for it. Whereas inline, it can be accurate, but there's things like you have to keep the conveyor clean, you have to keep the sensor clean, the supports. So there's a lot of things that can go wrong with inline weight check. It's still doable, but there's some things that you need to do to make sure that it's working perfectly. So yeah, it can be done, but it just depends on the application.
Andrew, have you ever implement a weight check rejection system or feedback loop at the sheeter, rounder, molder?
Or the divider or something, yeah. We have not done that. I mean, theoretically, it is possible. That's actually one thing I wanted to measure too. So, for example, on some cookie products where the dough is very consistent, actually volume can be a good indicator of weight. For some products, it doesn't work at all. Chocolate chip, it's not so good because it depends on the number of chocolate chips. But where there's a consistent density of a particular product, you can get a reasonable check on weight. Not precise, but a reasonable check. But lots of products you can't in bakery, especially where there's a lot of yeast or baking powder involved. So on the rounding, we've been asked a few times that some mechanical difficulties of being able to see and do the inline weight check, but I know there is inline weight check available. We have not done it at that point in time. We've done it a little bit later on after products are formed. So it is possible, but again, it's because the problem with inline weight check, as I'm sure anybody has done it, each one of these sensors is quite expensive, so it can add up very quickly. And then also the speed of the product moving. And then in the makeup area, typically you're using a lot of flour. And again, that can cause problems with build-up and making it not as accurate. So again, if you implement a good maintenance and sanitation process, so you're keeping the system very clean and operational, it'll work well. If there's some build up at different parts of the conveyor or the weight sensor, it can sometimes be a bit challenging.
Yeah. Well, the reason why I asked that question is because the dough divider operator is always is a key position in the bakery that that controls the quality for the end of the rest of the line, you know. So that position is really important. And if you've ever like implemented such a system where it replaces that position, I think that would be the tipping point of, you know, AI in the industry, right? So one of the reasons why is because these operators can have the experience and the knowledge to feel a dough, to understand what is the weight management, weight adjustment accordingly, right? So the entire shift, they're constantly going back and forth, weighing dough, adjusting, you know, dough weights and things like that, which is really unnecessary if you ask me with the technology that we know these days, right? So hopefully you get to implement one soon and I get to talk about it.
Yeah,
And
we're certainly working. It's certainly an active project because anybody who's worked in a bakery knows what do they call the divider? They call it the cash register of the bakery because, you know, giving away or not giving away, and in some places too, products are sold by weight. So it's absolutely critical that, you know, the weight control is good.
yeah.
Otherwise, you're going to get fines from, you know, various organisations, you know, the government or whatever. But yeah, you're right. It's something that
Yeah,
we're
if
actively
you
working on.
ever implement such a system, yeah, let me know. I would love to
I
talk
will. I will.
about it.
Yeah, that's a good question because actually, when we first got into Vision, it was one of our customers that actually asked us for the distinction between that because, um, you know, to understand your total process, you want to see the good, the bad, and the ugly, right? You want to understand, okay, what's the variation? But sometimes you also want to see, you know, just for the product that have been allowed to go through to packaging, what are the statistics? What's the variability there? And also, that customer in particular was using the data to provide reports to their customer. So, this is what we packed for you today, and here's what the range of measurements were, and for the key attributes, and sending it like a certificate of acceptance to the customer. And so they thought that was a powerful tool. So yes, so on the interface, it's giving you all data for the product. But once the data gets written to the database, it is actually kept total data for all products, good and bad. And then you have another, you can dissect the database just to say, okay, all good products, can you give me the data for that? And so that can then show you the variation of the product that's been shipped to the customer. And again, the purpose of the data is to give you more information about your process so that over time you can improve your processes to reduce that variation. And I think that's a lot of our customers are using it to demonstrate to their customer, hey, we're making improvements every day, which is, resulting in a more efficient process, effectively a lower cost or cost avoidance for their customers, which again, you're able to show them what you're doing to help them using facts. And that's very powerful discussion, especially when it comes to negotiations or comes to, quality standards and things like that.
Absolutely. Well, that's all the questions that we can handle today. Thank you, Andrew, for coming on and showing what you know about vision systems and about your system and your expertise in implementing these things. I hope the data collection doesn't scare anyone. It's pretty simple. All you got to do is rely on the KPM Analytics team to implement this. And if you have any more questions, go to kpmanalytics.com. So thank you, Andrew, for coming on. And thank you, everyone, for taking the time out of your day to come be with us today.
Thanks for
See
the
you later
opportunity.
at the BAKERview. Bye.